For this week's demo lab, we're going to do multivariate linear regression where we use more than one independent variable at a time. So you want to open up the data set and the code book, the attached syntax file, and then you can open up these now or later, but there's 3 different Excel files in the textbook. These are also just links that all work to click to download them. And we'll be using all of those during this demo lab. So first we need to choose independent variables to use. We're just going to use 2. And for this, this doesn't need to be the case for multivariate regression, but for the demo lab, you have to choose ones which have a significant relationship with your dependent variable. And again, we're using theism. And so it has to either be ratio level, ratio like, an indicator variable, or reference group set. So we need to find 2 that we want to use and that each have a bivariate significant relationship with theism. And there's a couple ways to this. We can create a correlation matrix. That's probably the easiest way to just look at a list of them and see which have p-values less than 0.05. Or we can run regressions, and that'll also show us, how substantive it is and more information about it. And so let's look at the code book. And get a sense of variables we could use. So like we can use age 3 cat we shouldn't use, right? Because this is ratio level, this is ordinal, but it's not enough to be ratio like. Same thing, we don't want these ones with 3 categories. We could use college degree. That's an indicator. We could use gender, we could use grass, use hours last week, right? We could use income inequality. Just looking through to see the types of variables that would work for an independent variable for linear regression. Okay, using through these. So I have a sense of some of them that might be interested in that could work. And so what I'm going to do is, here I'm going to make sure that I can see my syntax commands. I can also do that with edit options viewer, although I don't need to share my syntax for this part for my outputs on the document, but still, it's checked. Okay. So I'm going to turn weighting on. And again, the weight variable for this, I had named weight variable in the data set. I can also go data weight cases by. And then here's how to do a correlation matrix. So I'm going to put in theism as my first variable. And then I'm going to put in a bunch of others as well. And again, they just have a space between each. I can put as many as I want. So age, college degree, gender, W, grass, hours last week, quality. These intelligent ones, I remember those work. Proselytize, mental health. We could even do the mental health indicator. I don't need to do this many. I mean, you can run more than one. You don't have to just do the party ID. I probably don't want to do a that's probably not, okay. That's enough to fit on there. Let's run it. Hmm. Oh, these didn't work. Let's see. TM, age, college degree, gender, W, grass. Oh, this looks spelled wrong. Let's try it again. So, and then I'm going to look at this column. Again, if I want to do drop down, I'll do analyze, correlate, bivariate. I'll put in theism and any other variables I want. I can just put them in here and click OK. I don't need to add extra stuff because I'm really just looking at, here's theism. I'm just looking at this column and I'm looking at the p-value. So like you can see age, p is less than 0.5. So I could use age, I could use college degree, I could use, let's see, most of these. Yes, yes. Here you can see I can't use the intelligent blacks one. I can't use intelligent Hispanics. Can't use intelligent whites. Can't use phys health. Can't use the phys health indicator variable. But any of these other ones I can actually use. So I just have to choose which two I want to use. Again, the other option would be one at a time to do something like, let's say I want to look at age, right? I can run this and look at this p-value or even this p-value. And that's enough, but maybe I also want to look at something else to see kind of, oh, what kind of impact does this look to be having? Is this what I want to use? But all you need here is just two significant ones. So you can run a bunch of ones like that as well if you want. I think the correlation matrix is a little easier personally because you can do more at once. If I were to do this like a regression linear, put theism in here, independent variable in here. Okay, so what I'm going to use is pull views and own gun indicator. So let's get the information for these. So here's my coding, the question associated with it. So how conservative or liberal are you? Okay, so next I need to generate some type of summary statistics for each. And so for this, it says categorical variables produce a frequency table. So like for this one, it's just 0 or 1. I'm not going to want its like mean and median and stuff. I just want that. And for ratio level variables, summary statistics, 1 to 7, this one, I kind of want to see each percentage, but I also could do the mean and median. So I'll just do both for that one. So I go back to my syntax. Um, I have that here. So frequency table. And let's do that for pool views. And then I'll also do these summary statistics for pool views. And for these ones, I do need to share my syntax. Oops. Okay, let's run that. So we can see that about 36% of folks own a gun in their home or garage. The average full use is around a 4, which is moderate. And we can see that around just over a third of folks are at moderate. We have about 24% here, around 29% here, and then about 5% at the two edges. I wanted to use drop down. I could go analyze descriptives frequencies. And so for example, for poll views, if I want a frequency table, I have this already selected and I'm good to go. That's what I do for own gun indicator. I just do that with the frequency table. For this, if I want summary statistics, I go into statistics and I select the ones I want. And then I click OK. All right, so the next thing we're gonna do is run 3 linear regressions. So we're gonna do one with our first independent variable entheism, our second one, and then a multivariate one. And we're gonna run these both with weighting on and then weighting off so we can get the sample size. So again, our weighting on, name of the weight variable is weight variable. Our dependent variable is theism. And our first independent variable was pool views. Then we need to do the same thing with weighting off and run the first linear regression again for the sample size. We'll turn weighting back on, and this time we're using the own gun indicator. Turning weighting off, doing the same one again. Turning weighting back on. And then this time, just like how you did it with the reference group sets, we're just going to put them both in. Make sure that period stays at the end for it to run the command. So we have poll views, and then we have own gun indicator. Turning weighting off and running it one more time. Okay, so here's all my syntax. Again, I could also go analyze regression linear. I could put theism into the dependent, right? I'll put either own gun indicator or poll views, or then finally both in the independent. I'll add in my confidence intervals and descriptives, and I'll click OK, and I'll also turn weighting on and off, back and forth, right? So do not weight cases OK, weight cases by weight variable, okay, and just go back and forth on that as well. All right, so here's my first one. Second. Oh, was this weighting off or on? Let's see, this was weighted. That was what I thought. Weight off. Okay. Weight on. And weight off. Good. Okay. And then the last one. Oops. Did the wrong one there. Where was it? Hold on, let's go back. So this was just the gun and home garage. So that should be, and this was no waiting. So that was the descriptives here. Good. And then I went down to here. Okay. And then I needed the other parts of that one. Okay. We are done with SPSS. Although actually, I'll leave it open just so I have no, that's fine. I can use this. Okay. So this is a lot of stuff, right? Not easy to look at and interpret everything else. It's just kind of a lot. And so what we're going to do next is put it into a nice summary table. So for that, it's on the wrong spot, didn't I? This is all right here. Okay. So for that, we're going to use this Excel spreadsheet you can download from the chapter, or if you just click that link, it'll take you to the one with the chapter. And you can see there's a few different options here. So this one is if you had, like if you're doing model building, you had 5 different ones and then a full model. This is if you have a reference group set. But if you just have 2 ratio level variables or 2 indicator variables or a ratio and an indicator, we'll just use this first one. So I'm going to set this up, predicting theism. My data set is GSS 2022, and we'll see if I need to add any notes or coding stuff later. This tells me about what to do with coding. So my first independent variable was poll views. My second was own gun indicator. This one, my first model was just the poll views one. My second model was the own gun indicator. Then I have my full, which had both, like all my variables in it. Okay, so let's see about the coding here. If I go back to here, this is going to be 1 extremely liberal to 7 extremely conservative. An own gun indicator is going to be, right, 1 equals yes, right? They have a gun in their home. Okay. I don't need anything else then for coding, so that's fine. So we're going to start with just the first regression, which is this column. Okay, and so that's this first one right here. Where is it? Okay, so here's my R squared, 12.3%. Here's my overall significance, less than 0.001, so that's 3 asterisks. And then here's my y-intercept and my slope, and I'm going to want these. And look at both is less than 0.001, both are. And then here's my confidence intervals for them. And then here's my unweighted sample size. Okay, so we did the first one. Now we're going to move on to the second one, also bivariate. So we're doing the exact same thing, just with the next regression in the next column. So my R squared is 14.9%. P is less than 0.001 for the overall model. And here are my coefficients and slopes. So you see in the first one, right, there was no own gun indicator wasn't in it, so that's just blank. And here I'm going down to here. I'm not putting it here because I'm putting it on that own gun indicator row because that's the variable. We didn't have this one in it. Okay, let's see about these p-values, both less than 0.001 again. And our bounds, our confidence interval. And then finally the sample size. Okay, now we're on to the last one. So this is similar to what you did with the multivariate analysis. So, oops. Why do we have two descriptives here? Oh, this was for both. Okay. Sorry, this is my third one. So 1114. Yes. Okay. So let's see. Our R squared is 14.4%, which is interesting because I see that we had already like more than that, right? These don't like add up. They're definitely overlapping here in terms of what variance they're explaining. P-value is less than 0.001 for the overall model. And then we have these here. Let's just add the 1074 for unweighted. And then we have these ones to put in. So You can see this one is not significant anymore, actually. So I don't want any asterisks. It's more than 0.01. Okay, let's add in, right, so that thing popped up. I had to add this apostrophe before the negative to make it work. Okay, so here's my whole table. So I'm just gonna take a screenshot of it. Has all the info I need. It's going right here. Okay, so for our first bivariate regression model, it says what does R squared mean in real life context? So that's for poll views. So we're saying that political views, how liberal or conservative you are, that's our IV, explains 12.3%, that's R squared, of the variance in our DV, which is theism. Who would be predicted to have the highest and the lowest? So we can see that the slope is positive. So as poll views gets higher, theism also gets higher. So the highest would be an X of 7, right? That's the highest that poll views can go. And so then what would be the Y? So here our formula is Y equals 3.082 plus 0.380X. And I'm going to substitute in that 7 for the X. But I'm just going to use that predicted value calculator. Let's see. So we have 3.082. This is going to be poll views is 0.380. And I'm saying it's at a 7. So it's 5.742. And then what do these mean in context? So X equals 7 would be extremely conservative. That's the political views. And then Y equals 5.742. That's the theism. So if I go back to my code book for theism, a 5.472 is closer to the 6 than a 5, but it's almost at a 6. Let's see, it's like 3/4 of the way there. So between having doubts but believing and believing without doubts. So believing in God with only minor doubts. We could say few/minor doubts. Okay. Who would be predicted to be the lowest dependent variable value? So again, this is a positive slope, right? So as x increases, it gets bigger. So we want x to be as small as possible. And so the smallest one it could be here is a 1. And we can see, if we go to the context right now, that means extremely liberal. And if I go back here and I just change this to a 1, I can say this is extremely conservative, extremely liberal. We get a 3.462. And what does that mean? Let's see, that's between about halfway between 3 and 4. So believing in a higher power but not God to sometimes believing in God. So I'm just going to say it's between that. So somewhere between believing in a higher power and sometimes believing in God. So that would be our prediction for extreme liberals. This would be our prediction for extreme conservatives. Okay, what's the next one for the next one, which is an indicator variable? So here, right, our IV, which is whether or not someone has a gun in their home or garage, explains 14.9% of the variance in theism. Who would have the highest or lowest? This is again a positive slope. So the highest would be x equals 1, which means owns gun. And the lowest would be x equals 0, which means does not own gun. So here our formula is y equals a plus bx, so 2.923 plus 0.425x. So for this one, right, it's just going to be 2.923 plus that. And for this one, it's just going to be 2.923, the y-intercept. So if I go back to my predicted value calculator and I update this, so we have 0 for no gun and 1 for gun. And so you can see 0 is at 2.923 and 1 is at 3.348. And so if we go back, what does this mean? So we're predicting somebody who owns a gun is going to be almost halfway over, just over a third of the way between 3 and 4, like up above 3. So believing in a higher power to God some of the time. I'm just saying it's somewhere between believing in a higher power and occasionally believing in God. And then we're predicting somebody who doesn't own a gun is going to be just under that 3. So someone who's agnostic to higher power. So we'd say believing in a higher power, or let's just say with doubts. But maybe uncertain. Let me say that. Okay. Now we're going to interpret our multivariate table. So this last column here, we're going to graph it. Here, let's explain R squared first. So 14.4%. So collectively, political views and whether or not someone owns a gun. So our independent variables combined explains 14.4% of the variance in theism, in theistic views. Okay, so let's graph this. So there's a bunch of different options here. We're going to use the 2 lines one because we have an x-axis that we can use. We can use pole views from 1 to 7 on there. If we only had 2 indicator variables, we'd use something like this. I guess what is our other one? Your other one is just 0 or 1, so we only have 2 lines. Let's say we're using political views and age. Maybe I'd put age here, and then I'd use 3 lines. Maybe I'd do like a 20-year-old, a 50-year-old, and an 80-year-old. So anyway, we're going to use this one. So let's see. My intercept is 2.991. I'm just using this full model coefficients. My IV1, which is pole views, is 0.408, and my IV2, which is own gun, is negative 0.027. Okay, so the one that's going to go on the x-axis is going to have to be pole views, right? We can't put just 0 and 1 on the x-axis here unless we're doing a bar graph. So this is going to go from 1 to 7. So it says that's going to be these two, the IV for the x-axis, and it goes again from 1 to 7. We could look back up and see what we ran earlier for our minimum maximum, but we know there's people in both those categories. And then these are going to be the other one, which is going to be 0 or 1. No gun, owns gun. Okay, now we're going to have to change this. So this is going to be political views. 1, extremely liberal, to 7, extremely conservative. And it's going to go from 1 to 7. And then this is going to be theism, which goes from 1 atheist to 6 theists without doubts. Let's just say 6. Right, so we'll change this also then to go from 1 to 6. And here is our graph. Move this up a little bit. Take a screenshot of the graph. And a screenshot of my work. So we can see that as political views increase, theism increases. But we can also see that there's not really a difference once we control for theism among owning versus not owning a gun. Right? Whereas originally, if we had just done gun ownership, let's go back to the first one, then you'd actually see the second one, a gap of about 0.4. So there'd be a gap around like this size almost between the two lines. Well, there wouldn't be two lines, but anyway, we'd have a bar graph. But there would be this gap. But now that we've controlled, once we hold political views constant, so among conservatives or among moderates or among liberals, we no longer see a difference in gun ownership having an impact on theism. So whether you or not you own a gun doesn't really impact it much. Okay, so which IVs are and are not significant while controlling for the others? So again, we can see that political views is significant, right? It has a significant relationship with theism while controlling for gun ownership. And then gun ownership, right, had 0 asterisks. So it's not. It doesn't have a significant relationship with theism while controlling for political views. Who would have the highest or the lowest? So even though this one's not significant, we're just going to make our best prediction. And so we're going to use the sample slopes. So our formula here, our equation, is y equals a plus bx. So that would be political views, let's say, plus the x2. Let's just say own gun indicator. So what does that actually look like? It looks like this. Gee, forgot. Okay. So the highest, right, as this is a positive slope. So as this increases, theism predicted values are going up. So the highest would be poll views of 7, right? It goes from 1 to 7. And the lowest would be a poll views of 1. And then for gun ownership, this has a negative slope. So for every increase in this is going down, like the theism predictions. So somebody who's at a 1 is going to be lower than somebody at a 0, right? Because the 1's going to add a negative number and the 0 is not. So the highest it could be would be if this is a 0, and the lowest it would be is if this was a 1. And if you're not sure on that, you could always put them in here and you can just play with the different combinations if you don't want to kind of think about it mathematically and see which are higher and which are lower. Because you have basically poll views is either going to be 1 or 7. Gun indicator is going to be 0 or 1. So you could have 1 and 0, 1 and 1, 7 and 0, 7 and 1. You have 4 kind of options. Okay, so we said that here poll views is 7, which is extremely conservative. no gun, and extremely liberal with gun. Okay, so I have all three here. So my value here was a 7 and a 0. And that's going to be y equals 5.767. And if we look at if this was a 1, so extremely liberal, and oops, sorry, with the gun, that'd be 3.292. So we go back to our code book. See, if 5.767 is over 3/4 of the way from 5 to 6, which was very similar to something we had before, right here. And then a 3.2 is just a little bit more than 3 on a way to 2. Um, let's see, so about 3.3. Do we have something like that already? Oh, like this is close. Again, if this was something like income or something, we could describe it more specifically, but okay. The unstandardized slope. So this is not in the chart actually. So when I said we were done with SPSS, actually, we didn't capture this. So we need to figure out, the question is, which of these is, we'll just, sorry, these are the unstandardized slopes. We have them. I was jumping ahead to number 16. So number 15, the unstandardized slopes are 0.408 for pole views and negative 0.027 for gun ownership, the own gun indicator. So what do these actually mean? So we interpret it the same way we did before. We're just adding at the end while controlling for the other variable or while holding the other variable constant. So for pole views, we're saying for every 1 unit increase in pole views in political views, so this is becoming more conservative from 1 at extremely liberal to 7 at extremely conservative. Yeah, if this was something like age, I'd say like for every 1 year older someone is, but this let me say every 1 unit increase is associated with a predicted 0.408 increase in theism. So that's becoming more theistic on a 1 atheist to 6 theist without doubts scale. Okay. And then for we have to add while controlling for gun ownership or while holding gun ownership constant. Okay, so what that means is that well, I'll explain it. It'll be easier with the other one with the lines there. Okay. And then for gun ownership, we're saying someone who owns a gun, right? Because it's only an increase from 0 to 1, that's it. So it's going to be, would be predicted to be 0.03 units lower in their theism. Compared to someone who does not own a gun or doesn't have a gun in their home or garage. And again, we have to add while controlling for or while holding political views constant. So what this is saying is that at any given political views, right, this is the difference, is the negative 0.03. That's our slope at that. Or for any while holding gun ownership constant, right, this is the difference we're seeing in political views. You can see the lines are the same for both in terms of what that slope looks like. Which IV contributes more? So here, right, I mean, we might be able to tell a little bit from this, but we don't know the variation of political views and gun ownership. But in general, right, like it's hard to just tell from this because this is only 0 or 1, and this goes from 1 to 7. And so what we're going to do is we're going to use the standardized slopes, which are the ones that put it into for every 1 standard deviation increase in x, it's whatever the standardized slope value standard deviation increase in y is what it's associated with. So let's go back to here. I'm just taking the coefficients box from the output from the multivariate model. And I don't need anything except for this last one. So here are our regular slopes on standardized, but here's the standardized ones. Oops, I took the wrong one. That was not the multivariate one. Here we go. Okay, so you can see unstandardized, and then here's my standardized. So where it says beta slope, so for pole views, it's 0.381. So for every 1 standard deviation increase in pole views, we're saying that there is a 0.38 standard deviation increase in theism. And then for gun ownership, it's negative 0.008. So we're saying for every 1 unit increase in, 1 standard deviation increase in gun ownership, there's a 0.008 decrease of standard deviations in theism. So now we can compare these. We don't care if it's negative or positive. We just want to see their absolute value of kind of which is further from 0. And so pole views is contributing more towards our prediction of theism than gun ownership, as it has a higher absolute value for its standardized slope. Okay, so we can compare it, right? We can't compare here, but we can compare here and say this one's having more of an impact or effect. How do my multivariate models compare? So when I look at this, what I can see is that originally they're both significant, but once I control for political views, gun ownership no longer matters. So this is almost like we're saying it's spurious, right? That like actually maybe political views, there's enough of like a difference in terms of who owns or doesn't own guns based on their political views, and that's doing that. Or maybe it's that gun ownership. Yeah, so I mean there must be some correlation there, but what we're seeing is that the relationship, that initial relationship we saw between gun ownership and theism is explained by political views, right? It goes away. It's no longer significant. So here there is this relationship, here there's not, right? They're not having independent effects. We can see that like these don't add up to this, right? That it's not that the slopes stay similar. This one went from 0.4 to almost 0. This one actually slightly increased. So, right, so gun ownership was significant in the bivariate model, but not in the multivariate model. And its slope fell to close to 0 in the multivariate model. So again, maybe that means that well, there was a relationship between gun ownership and theism. It could be spurious, with political views explaining that relationship. More conservative equals more likely to own a gun and more theistic, right? And the opposite. So if we had seen this stay significant, but like drop in half, then it would have partially explained it. if we had seen this kind of stay the same, then we would say they're having basically independent effects. Um, if we had seen this go away, then we'd say this one's explaining that one away, etc. So you're just gonna have to look and see what's going on here, if anything. So we are done. I'm going to show you two others just to, we're not going to go through the whole thing, but just to show you kind of what a graph might look a little different too. And so let's start with, let's do poll views and age. So we already have poll views, good. And then I'm just going to change own gun indicator to age. So now we're going to have two ratio-like or ratio level variables. Okay, so 1, 2, 3, 4, 5, 6 here. So we already talked about poll views, but if we look at age, we say that initially age is explaining about 4% of variance in theism. It is significant. And every year increase is associated with about a 0.02 increase in theism. So like a 10-year increase would be 0.18 or like almost 0.2. So that would be like a 50-year, somebody who's 50 years older would be about 1 unit higher on that 1 to 6 or 1 to 7, whatever the theism scale was. 1 to 6. So like 50 years would be about a 1 unit increase. And then let's see what happens in our multivariate model. So here we can see they're both still significant, 0.358 and 0.015. So if we look at the slopes, age 0.015, it was 0.018, so it's pretty similar. And this one was 0.38, and here it is 0.36. So they're both pretty similar. They're slightly smaller, right? There's a little bit of an overlap. Maybe as folks get older, they're more likely to be conservative. But in general, right, they're pretty much staying the same. The significance isn't really changing. And so we're saying these have pretty independent effects, right? Age and political views are both having independent effects on theism, both positive relationships. But it's one's not kind of explaining away the other or really impacting that substantially. So when I go to graph this, I'll use the same one. So I have my pole view. So I have my intercept. I have pole views, and I have age. And here, I could put either one on the scale. So I could leave pole views here, and I could do lines with age. It's up to me to kind of choose that. I'll do that first because it's kind of already set up that way. And so I could do, let's say, 18-year-old, and let's say 65-year-old. And so then here you can see what's happening, right? There's this gap. So this is the gap for between an 18 and 65-year-old while holding political views constant. So at extreme conservative or extreme liberal or whatever it is, right? This is the gap. That's that slope. So I mean a 1 year increase would show us, like if I did 19 years old, you can see that's the 0.015. And then we can see that while holding age constant, we can see what the slope is here. I could also do it the opposite way if I want. Well, I could do 3 lines, for example. So if I did that, I would have to set everything up, but I could do 18, 35, and 65, for example, as my different ages. So I can show more lines. I could even do 20, 40, 60, 80, whatever I want to do kind of in that. My other option is to switch these. And so if I want my x-axis to be age, I'm going to change here. I'm going to make sure that my slope, even though like is not my slope, the x-axis one, regardless of the order here, is going above. right, where it says the slope for the x-axis and the lines one's going here. That's just how it has to work with the template. And so this is going 18 to, I forget, it's 89 maybe, 89 plus. And then here we're having political views. So let's just say we do 2 and 6 for um, liberal and conservative. Oh, whoops, I messed it up. Liberal, conservative. I got confused because the age ones were numbers, right? And then I need to switch this. So instead, this is going to be age. That's going to go from like 18 to 89. This will stay the same. And so here's my graph then for that of comparing liberals and conservatives. Again, I could do 3 lines. I could do liberal, conservative, and moderate. Um, I could choose extremely liberal and extremely conservative, right? It's up to me kind of what I show. But you can see this gap here that's consistent, and you can see the change of political views while we hold age constant. Um, sorry, and I would change this to age in years. Okay. And then the last one I want to show you was what if we did 2 indicator variables? So here I'm doing gender and gun ownership. We already did a gun ownership one, but let's just do a gender one. Right there. Let's compare. Let's just run it. Show you graphing it. Okay, you can see they're both significant here. I didn't run I could. Let's just see. So gender was also originally significant with a slope of 0.427. You can see it's actually slightly increased here. Gun ownership 0.365, and it was originally 0.425. So it fell just a little bit. So gender is explaining a tiny bit of the relationship between gun ownership and theism, but mostly they're mostly independent, but it's a little bit of that overlap, right? Um, maybe men are more likely to have guns and anyway, okay. So what do I do with this when I'm graphing it? So because these are both just only 0 or 1, I don't want to make lines. Here it is. I want to go to this one that says 2 indicators bar graph. So I'm going to put in my intercepts and my slopes here. And then I'm going to, for my IV 1.365, that was the gun ownership. So this is no gun, yes gun. And then this one, IV2, was man and woman. And then IV1 again was gun ownership. And the dependent variable was theism, which went from 1 to 6. I could add those labels in, but I just want to show you kind of overall what this looks like. Okay, so here you can see that this is our graph. So we're basically showing the 4 different options or categories that could be. So we can see the comparison of, right, men with or without a gun, women with or without a gun, men to women who don't have a gun, men to women who don't do, etc. And so this would be how you would graph it if you were just using 2 indicator variables.